What is up, ladies and gentlemen? As promised, we are going to do a density column. This is kind of not, it's not really an experiment. It's more just to prove that this can be done, that density is a real thing, and that if you can harness the powers of density, you can do some pretty cool stuff. So a lot of the stuff that we're going to use contains sugar, or at least a couple of them. And you can actually do this experiment with nothing but sugar and water, with different amounts of sugar in it. So if you have 1 cup of water and you add a cup of sugar to that, that's going to be pretty dense. But if you have a cup of water and you put a half a cup of sugar in it, that liquid is going to be a little less dense. And you can do different concentrations of sugar and just dye them different colors and do this very same experiment. It's just hard to get the layers to separate. So the first thing we're going to use is the thing that I think contains the most sugar. It's super sweet. And that's going to be honey. So I'm going to take this jar of honey, and then we're going to try to get about anywhere from 50 to 100 mils in this jar. So it may take us just a second. I'm going to squeeze pretty hard here. So there we are, about the 50 mil mark. I'm getting close anyway. We'll get as much as this thing has in it. And if you can try this at home, the less amount of air that you have in your honey, the better it's going to be. Because that air is a fluid too. That's going to rise to the top of this entire density column. Because air is a fluid, just like all this stuff that we're putting in here today. And it's less dense than everything that's in here. So it's definitely going to rise to the top. The next thing we have is, some of you all that do candy making or anything like that have seen this before. This is corn syrup. This is in a lot of stuff that you eat. It's high fructose corn syrup. You've heard of that, right? It's not the best thing in the world for you, but it makes fantastic density columns. So this has got a little bit less sugar than honey does, and if you were to taste it, it tastes a little less sweet. I'm going to pop this sucker open, and then we're going to see, we're going to dunk, I don't know, let's do another 100 mils. Or another 50 mils at least. So this is a little bit lighter colored than the honey is. And the problem with this experiment sometimes is if you pour too fast, then things tend to mix. And you really don't want these mixing together. But you can definitely tell now that that corn syrup that's going on top is a little lighter colored than the honey that's on the bottom. And then it's pretty much sitting on top just like oil and water would. Let's put a little bit more corn syrup just to get that filled up there. And over time, as this kind of settles and separates, it'll separate even more than what it is now. So you can tell that if I stick my hand kind of behind here, that the corn syrup is definitely sitting on top of that honey. So we've got honey down here at the bottom. We got corn syrup that's kind of there in the middle. Well, we got to find something that's even less dense than corn syrup. So a lot of people like to use, at this point, you can use milk. Actually, is a little bit less dense than corn syrup. So you could put milk on top of this. That's kind of hard to do. So we're going to skip the milk for right now. And we're going to go with Dawn dish soap. So this is going to be kind of cool to see this happen. In order to keep this not mixing together, I'm going to try to use a little glass pipette. Let's see if that works. And if it doesn't, if it goes too slow, then we'll use something else. Yeah, that's going to go a little bit too slow for us. So we're just going to dump this in as is. We'll just try to go pretty slow. And you can probably tell even that viscosity is kind of how sticky a substance is, or how it flows really is what it is. And you can tell that these less dense materials that we're dumping in on top of here are a lot less viscous, which means they're a little bit more flowy. And this is going to give us some pretty good color separation. So at the very bottom, you can still see our corn syrup. that's there. And then we have Dawn dish detergent, or I think it's just regular hand soap. But it's the Blue Dawn. It's the one with the little duck on front of it. So we got a few air bubbles in that one, but it's not too bad. Like I said before, you can always do this at home. If you have these materials that are there, and if you do it at home, please send us a picture, send us a video of what you did. So if we look back down at the bottom here, you can see that our corn syrup's still kind of sitting down here at the bottom. I'm sorry, our honey's here at the bottom. It's really dark. The corn syrup starts about here, comes up. You can actually see some of the honey is starting to flow upwards just because it's tagging onto these air bubbles that are coming towards the top. So you may even see some discoloration from the honey, some brown coming up through our soap layer here in just a second, but that's going to be okay. All right, let's go on to our next layer. If you had to take a guess, what do you think would go on top of soap? What would be less dense than soap? I bet you probably didn't guess that it was going to be water, which is exactly what we're going to use. But just to make this cool, we've colored our water green. So we're going to use green water. And this, I know, will go through our little glass pipette. So this will keep it from, it's really a Venturi funnel, but this will keep it from separating. Well, I'll actually show it separate, but this will keep it kind of from dunking down in too far and making too many bubbles for us. And this is just plain green colored water. It's kind of hard to keep from getting those soap bubbles in this one. If you did it at home and you went a little slower than I did, then you might be able to get it right. All right. There's our water layer. Water's a little bit less dense. I bet everybody knows probably what I'm going to use next. Let's move the camera out so y'all can get a little bit better shot. So here down at the bottom, we still have our honey, and then our corn syrup, and then Dawn dish soap, and then we have water that's a little less dense than that. So let's go on. What is less dense than water? You guessed it. Oil. So we're going to use some oil in this one. And this one you don't have to worry too much. You'll even see the oil kind of dunk down in the water. Use our little funnel guy here. Made a mess. Really cool, clear separation in between these two. Got a little bit more oil to add. There we go. All right, so we're looking pretty good so far. We've got a lot of different layers here that are looking pretty cool. Let's take a picture up of this whole thing after we're done with it. We've got one more layer we're going to put on. And if you can think to yourself, what's lighter than oil? Or what's less dense than oil? A lot of times when we say the word lighter, we mean less dense. So one thing that we have here is isopropyl alcohol. You can use lamp oil, like the stuff that you use for like a mosquito lamp outside, but isopropyl alcohol is even lighter than oil is. So this one I've got it dyed red so that our colors look a little bit different. And they don't all mix together. I think that's probably going to be enough. So there we have it. So why in the world do we have all these layers that are completely separated from one another? Why isn't everything mixing together? It's because of that property of density. We have the lowest density liquids on top and the highest density liquids down here towards the bottom. We've got really, really dense honey that is sitting right underneath a little bit less dense corn syrup. We have some Blue Dawn dish liquid, and something cool will happen in between these where they kind of mix together because the dish liquid is it's water soluble. So these two are probably over time going to mix together, but for right now they have different densities, and you kind of see a little bit of that happening. We all know that oil and water don't mix, and that's kind of where we have the most clear separation. That line here is really, really sharp. And then we have a pretty sharp line in between our oil and our isopropyl alcohol. See if I can get you guys straightened up here. Okay, now we got one more kind of fun thing we're going to do with this. We're going to drop some different things down into this density column. So the first thing I've got, if we knew the densities of every single one of these layers, you could tell what the density of different object is. So the first one we're going to use is a paper clip. I'm going to drop this kind of down the side, and we're going to see kind of where it winds up. There goes the paper clip. You might not have caught that, but our paper clip, you probably guessed this, has sunk all the way to the bottom. So the next thing I've got is a foil ball, a ball of tin foil. Which layer do you think it's going to wind up in? How dense do you think it is? Oh. Our foil ball stays right there at the top because it's less dense than the alcohol. Actually, it filled up with alcohol, so now it's sinking. Oh, that was cool. So you actually got to see it fall. So as it got saturated with alcohol, the air got pushed out, which is really, really less dense than anything in here, air is. So it filled up with the alcohol, which made the density less or more in this, and it dropped down through that layer. So if we sit here and watch this over time, I bet we might see that that foil ball looks like it's pushing down through the oil layer also. If we let this sit here long enough, we might actually see it drop through that layer as well. So let's see if we can get it to focus a little better for us. All right, the next thing I've got is an almond. So we're going to drop our almond in there. We'll see which layer our almond winds up. You can take a guess at how dense you think an almond is. I'm going to drop it in the back here. Actually got to see it push through that layer. So our almond sits right here in between our soap and our water layer. So If you just had a bowl of water at your house and you had some almonds, you want to see which one was heavier, your almond's going to sink to the bottom of it. Another thing I've got is a battery. Hopefully this doesn't do anything weird. I have a feeling it's going to go all the way to the bottom just because our paperclip did, but who knows? We'll see. It's science. There goes our battery all the way down to the bottom. And then we have a foam ball. Let's see what happens to it. Foam ball, pretty simple, pretty easy. Probably guessed that. Our foam ball is going to sit up there at the top. So even solids have a density. And density, if you remember, is just the mass divided by volume.